This is a review from what we did before, so this should look somewhat familiar. It says that they vary inversely, and that's y equals k over x. Okay, and they give you a y and they give you an x. So 1 equals k divided by 10. You're just substituting those numbers in for y and x. What does k equal in this case? Jayla, are you there? Are you able to see my screen?
Yeah, I am.
Okay, what does k equal in this case?
10.
10, perfect. So then you rewrite the equation y equals 10 divided by x, okay? And then you substitute this value for now notice that this answer is out and this answer is out because they're the wrong equations. And then we're going to put -6 in for x. So y equals 10 divided by -6, which is -5/3.
Okay. I'll share my screen.
Okay, so this next one is basically the same. I will snip it, but it's going to be the same setup here. We're gonna write an equation, and then we're gonna solve it for the variable k, and so on. So let me get that in my screen. All right, and I will share my screen. Okay, so again, you're looking for that keyword inversely. That tells you that it's y equals k over x. So that's got to be totally cemented before you go and take this test or quiz or whatever you got coming up. They give you an x, they give you a y. They tell you y is 10, x is -3. Can you solve this for k for me?
Would it be -3?
You're gonna clear the -3 by multiplying both sides by -3. And you see that k is -30. So just like in the last problem, you're going to rewrite the equation. Y equals -30 over x. And I immediately see that, okay, those two are out. They're the wrong equations. So then they say, okay, x is 2. So you substitute that in. So y equals -30 divided by 2, which is -15.
Okay. Oh, that's actually pretty easy.
Yes. The only thing that can make it more complicated would be the types of numbers they choose, because the process is exactly the same.
Right. Okay. I guess on to the next problem.
All right, so look at the answers there. Do you see the first equation there? Y equals 156 over x, y equals 25 minus x, y equals 156x, y equals x over 156x. If you look back at both of the previous problems, either in your notes or you just think back to it, the variable was always on the bottom because it was k over x. So this means that the only possible answer is letter A. Now we can work through it, but letter A is the only one with variable x on the bottom.
And so can I just go off of that if there's like,
yes.
There's
if it's
inversely,
yes.
Okay, that actually helps me then. Cool. All right.
Okay, so let me grab this, but I think we may have to just look at the answers here to be able to do this. I may just have to talk you through this one. So
Oh wait, I can use Desmos, huh?
yeah, could you just scroll down to the rest of the answers? I want to
Yeah.
have you, I want to see what else they got there. Okay, keep going. Interesting. Okay, so go to Desmos if you don't mind on your screen. It's the graphing calculator, perfect. And then graph y equals, it's not loaded yet, y equals 1 divided by x, 1/x. Now, do you see how the graph is in the top right and then the bottom left?
Mm-hmm.
Go back to your other tab there, and you'll see that only the last two graphs have that shape. Do you see that? Like it could be that one or the one below. If you scroll up, you'll see that the other two are in the wrong quadrant.
Right.
Okay, so now let's go back to Desmos, and in the second line there, graph y equals 37 divided by x. Okay, now where is it relative to the original graph? You can see it's further out. Okay, so like go ahead, go back to Desmos and look for a point on that blue line. Like see how it's kind of near 6,6.
Yeah.
Okay, go back to your quiz, and between those two graphs, the other tab there, see which one it looks to be closer, and it looks like that one is the correct answer.
Yes.
Okay. Great. All right. So number 5, let's, in that second position, let's graph -23 over x. Keep that one the same, but the second one, graph -23 divided by x. Now, what you notice first is that it switches quadrants. It's now top left and bottom right.
Mm-hmm.
So that'll probably get us down to two answers. It's either that one, that first one there, or it's that last one there. And you kind of want to do the same thing. You want to go back and pick a point on that new curve. If you want to go back to the other tab there, like maybe -4,6, like that looks pretty close to me, and see if there's something near it on the graph there.
Yeah. Whoa.
I think you went by it.
Yeah. This one.
Yes. So notice that the negative switches the quadrants, and then the number that was on top, it stretched it.
Right. Okay.
Okay. So when you look at question 6, and I'm gonna share my screen on this one because we can talk through this a little bit together, and then you'll be able to very quickly be able to find the right graph after we do a quick dialogue on this.
Mm-hmm.
So the -2, what it does, the -2 up here, it causes the graph, like this is the original graph. The -2 causes it to switch quadrants. So it's now going to be top left, bottom right. The 2 stretches it. Okay. And then this -7 moves it down. So you're looking for three things. You're looking for a graph in the the top left, which is the second quadrant, and the quadrant 4, because that's the bottom right. You're looking for something that's been stretched, and then maybe more importantly is down 7. So you'll see maybe a horizontal line there. So if you want to go back and share your screen, we'll probably be able to pick it out pretty quickly. Desmos would also be very useful. You can use the same technique we just did, where you graph it and you look for a point. So see how that one's moved down but it's not in the right quadrants.
Right.
The next one is moved up. That's no good because we want it to move down. The next one's letter C is moved up also. So it must be letter D. And you really don't need to talk about domain and range, but we'll get into that when it does matter for these problems.
Okay.
All right, so for this one, I do want you to just go ahead and graph it in Desmos, and we'll just take a look and see like, well, which one is the same.
X plus 5. Oops. Okay. And then do I just add y equals
You got
1?
You have to put a +1 to the right of it.
Oh,
So,
okay.
yeah, right there. Perfect. Okay. So let's just talk about this real quick because that negative caused it to switch quadrants. See how it's sort of top left, bottom right. The +5 there moved it left 5, and the +1 moved it up 1.
Right.
Okay, and that's all from the parent graph. So, but in terms of like how to answer this, like you want to go find one that looks like this because they're giving you the graphs.
Okay.
So let's go look at them one at a time, and I'll help you work through it. So that one's looking pretty good. Okay, but let's just see if there's any others that are, like is that the right one? The second one is in the wrong quadrants. The third one is in the wrong quadrants. Like it's that, but that last one looks kind of good also, doesn't it?
Mm-hmm.
So that's where we got to be careful and be like, okay, well, is that it, or is it something else? Can you scroll up to, no. Okay, so what's different is the domain and the range. Do you see in that top one there's the domain is all real numbers except 5. The bottom one, it says that all real numbers except -5. So go back to the original question, top part of the question. And do you see that it's x plus 5 in the bottom?
Yeah.
Okay. What value of x makes the bottom 0? What number when you add it to 5 gets you to 0?
-5.
-5. So the -5 is the problem. So if you scroll down to letter D, it says that all real numbers except -5 because that's where you divide by 0.
Mm-hmm.
Does that we covered that last time? It's a little bit of a review, but is that okay?
Yeah.
All right. Now, do you want me to show you more of these problems, or is it okay for us to work it out this way?
No, it's okay to work out this way. I'm understanding it.
Okay. All right. So we're good. This question is answered.
Yes.
So if you, again, probably just want to graph this one for me, please.
And then it was 6x minus 1. Okay. 0.5.
Did you get it down to 2, or is it just that one you feel pretty good about? So it could be the bottom one, right?
Yeah, I'm thinking it's the bottom one because it's at 0.5 and negative 0.5 would make it 0.
Okay, but they're asking about the like domain, and they're referring to, if you go back to the original question, where the bottom equals 0. So where does 4x minus 2 equal 0? So if you set 4x minus 2 equal to 0, if you have some paper and you solve that for x, you would add 2 to both sides, and that would produce 4x equals 2. And then you would divide both sides by 4, and x would equal 1/2. So if you scroll back up to the original question, there at the top, can you visualize 4 times 1/2 minus 2? Does that equal 0?
No.
Okay, let me grab this. And I'll share my screen. So the truth is that the just graphing it will work most of the time, but you may need to do just a couple other things. So I'm sharing my screen now, and what I was trying to get across. I know verbally isn't as good as visual. The domain is based on setting the bottom equal to 0. 4x minus 2 equal to 0, and I was asking you to solve for x. So you're going to add 2 to both sides. 4x equals 2. Divide by 4, so x equals 1/2. Okay. And what I was asking you, do you see that 4 times, and I'm looking at this up here, 4 times 1/2 minus 2, does that equal 0? 2 minus 2, yes, it does.
Oh.
So when x is 1/2, this is the excluded value.
Okay.
So that's why the domain, I think if you go back and share your screen, you'll see that it's letter B, because letter B says everything but 1/2.
Yes. It does. Okay. Got it. On to the next one. This is like it.
It's just like it. So can you graph it and decide between 2 graphs? I'm going to just step away for 30 seconds and I'll be right back.
Okay.
Okay, do you have it down to 2 graphs?
Yes. I have it down to the 2 middle graphs.
Yeah, I agree. Now, do you see that the denominator is 4x plus 10?
Yeah.
You have to set that equal to 0. Solve for x, just like I showed you. And then you're looking for that number. So do you have some paper there to work through that?
Yes. 10. Negative 5/2.
Okay, and that is negative 2.5. So that helps you to say, okay, it's all the numbers except negative 2.5.
Yes.
Perfect.
Okay. Cool. And then you always set the denominator to equal 0?
Yes.
Okay.
So go ahead and graph this one, and we'll do the same thing too.
So it's either this one or this one.
So it's all real numbers except I'm not able to see the bottom of that screen. If you want to just scroll down just a little bit. Okay, yeah. So you want to set the denominator equal to 0 and see what?
4.
4. So you want to choose a different graph, I guess, letter A.
Yes.
Looks good. Perfect. All right. So why don't I grab a snip of this one? Could you just scroll down and see if there's any other graphing ones?
I doubt there is, because I think this is getting into 7.3.
Sure. Yeah. Okay. So let's go back up to the first question. Wow, there's a lot here. All right.
I know.
Well, we got time.
Yeah.
So the I'm gonna share my screen. Actually, I better grab all the questions, all the possibilities. All right. So share my screen. All right. So the way this question is written is that you're supposed to factor the top and the bottom separately. So do either of these look familiar to you? Like, are you like, oh, I know that one, or I know how to do the one on the top? They're two different types, but are either of these familiar to you?
No.
Okay, so the top is what's called an A equals 1 problem, and it's referring to this number out here. And you're looking for two numbers that multiply to -2 but add up to 1. So you have to multiply to -2 and then add to +1, that middle there. So in this case, I'll just write the answer. It's x plus 2, x minus 1, because 2 and -1 multiply to -2 and they add up to +1. Now the bottom is what's called difference of squares. Okay, and it's of this form: a squared minus b squared. And you probably saw this at some point, but it's a minus b, a plus b. So what number squared gives you 4? Do you recall?
2.
2. So your a is x and your b is 2. So this becomes x minus 2, x plus 2. All right. Now notice that these cancel, cancel. Okay. And what you're left with is x minus 1 over 2, which means it could be either of these. Although they look the same. What am I missing here? Are these the same? Because this is also the same.
Yeah, they are the same.
That's why I'm asking. Okay. So
Yeah.
so I believe there's an error in this. You may want to contact your instructor.
Same with the bottom too.
Yeah.
I'm just writing this down really quickly.
Okay. So whenever you get caught up here, I want to talk about how we determine this part on the right.
Okay. Okay, I'm ready.
So the part on the right here is determined by the slashes. And what you do is you set x plus 2, because that's what you canceled, equal to 0. And then you solve it. So you get x equals -2. And it's just an oddity here, but you end up just saying does not equal. I mean, that's really how it should be started. But it's the one that cancels. That's what you're writing down here on the right. So I can't, they're exactly the same. I can't tell you which one to answer, but what I can tell you is mark it, contact your instructor, and like let them know, hey, take a snip and say, hey, they're exactly the same. What do you want me to do?
Right. Okay. I will.
All right. So whenever you're ready, go ahead and share your screen and we'll look at the next one together. We'll probably have to work through most of these together because of the way that they're written here.
Yeah. Okay.
Did you get a spring break? Or are you going on spring break? What's your situation?
My spring break was actually last week,
Okay.
so that's why I didn't have any tutoring sessions booked.
All right. So kind of a little
Yeah.
2 months here and you'll be done, or maybe less.
Yeah. And then I'm going to a medical assisting school,
That's great.
so that'll be fun.
That's great.
But yeah.
Okay, so we're going to factor the numerator here. And it's this type where there's a 1 in front of the x squared. And what you're looking for is numbers that multiply to 48 but add up to -14. All right.
Okay.
And so for example here, I'm gonna help here. They're both negative, like -1 times -48. Do you agree that those multiply to 48?
Yeah.
But they do not add up to -14. They add up to -49. So how about -2, -24? Nope. -3, -16, -4, -12, -6, -8. Now I stop. The reason you stop is because you're about to wrap around on your list. So hopefully you see that these last two add up to -14. Do you see that?
Yes.
So the top becomes x minus 6, x minus 8. So whatever these pair of numbers are, they go with x, and you create what are called these binomial pairs, which you don't need to know the name of, but you do need to know how to write all these out and then figure out which ones add up to what you want. Now on the bottom, it's kind of the same deal here. What are all the factors of 36? And you can list them or not, but can you see any of them that add up to -12? And do any of them just jump out at you that you might write down?
Like the add up to 12.
-12, because it
2, 3, and 4.
so
Yeah,
these are all the
64.
right. Now notice the top had an x minus 6. Okay, and that's a hint here. Like there's got to be a cancellation. So like use the information from the top or the bottom to help the other way, because like you're going to cancel one of these, so it should be there. So notice these cancel, and just like I mentioned before, you have to set x minus 6 equal to 0, but it's really a not equal to 0 because you cancel them. You add 6 to both sides, so x does not equal 6. So that means it's either this one or this one.
And I'm gonna say it's A.
Sure looks like it's A. Now, please tell me, I really hope you've seen this before, all this stuff on the right. Like you've seen it before. Maybe don't know how to do it perfectly, but have you seen it?
Yeah.
Okay.
I hate doing these problems.
Yeah.
But yeah, I will share my screen now. Okay.
All right. So this one is a little bit different. It's different because there's nothing to cancel on the top and the bottom. Do you see that? There is So I hate using the word like trick question, but there's nothing, there's absolutely nothing to do in this problem. Like it's done.
Oh, oh,
It's
okay.
it's already done. So how do we decide what answer to choose? Well, it took me a moment to look through them, but the third answer there tells you what I just said. It's already done. It's already simplified.
Mm. So when there's only like one number on top, it's already simplified?
Well, there's nothing to cancel, I guess is what it really, like 14 should have been done first, because then I think you would have followed. So what cancels in the top and the bottom on 14?
X plus 10 and X plus 10.
Yes. Now, when we canceled it, what did I write? What did I show in red? So let me share my screen here, because I'm
It
always
was
trying to
like
ask you.
7 over X plus 9.
That's what it reduces to. But let me just share my screen real quick. This part in red, that's how you figure
Mhm.
out the what it X does not equal. So in your problem, you're going to set X plus 10 not equal to 0, because that's the thing you canceled on the top and the bottom.
Mhm. Right.
So go ahead and share your screen back, please. That's perfect. That's it.
Yeah. Okay. Cool. Um.
So this one's different, unfortunately, than the last ones.
Uh,
So no, that's bad. That's saying the general case is the exception. Um, so good try. Like, let me share my screen here, and we'll work through it together. And and I know factoring it, like I don't think factoring is very interesting. But there are like 10 different types of factoring, and the a equals 1 that we just did is one of them. The difference of squares is one of them. This one for this problem is called the GCF, the greatest common factor. And the greatest common factor can be a number, a letter meaning variable, or it can be both. So when you look at the numerator here, just the numerator here, you look at the lowest exponent. So what is lower between x to the fifth and x to the fourth?
X to the fifth and X to the fourth.
Which is the smaller
X
number? It's
to
all
the
about
third. Oh, sorry. X to the fourth.
x to the fourth. So we factor out an x to the fourth from both. And you've probably seen this where it goes on the outside of the parentheses. What you're really doing is you're dividing each of these by x to the fourth. Okay, so like this one on the right is probably easier. Do you see how they cancel?
Yes.
Okay, so that puts just a 3 right here. Now there's x to the fifth here. That means x times x times x times x times x, and then the 4, x times x times x times x. Maybe you already know this, but they all cancel except for that one. So there's just one x left over.
And it can't. They all. That one is left over because it doesn't have an X under it, right?
That's right.
I'm
That's exactly
guessing.
right.
Okay.
Yes. Now, all this work that we just did here is for the numerator. The denominator goes right down here. That's 6x to the fifth. Okay. Now, what we can cancel, and I'm going to do it in a different color, is this, what I'm circling here and here. It's x times x times x times x. There's 4 of them. And then on the bottom, there are 5 of them. And we're just doing this part. I do appreciate you trying to follow along here, because I know this isn't, it's not really interesting, and it's a lot here. There's a lot of synthesis going on.
Yeah.
So what's left over is 1x on the bottom. Do you see that? There's none on the top.
Yeah.
So the top becomes x minus 3 because those are all gone. The bottom, though, there is 1x left over, and it goes back with the 6. So out of these options, it could be, I'm sorry, I messed up here. There's a 5 here. So there's a 5 there. So it could be, it can only be this one on the bottom, or sorry, it's either one or the other, right?
Mm-hmm.
Because they're both the same. Now, no, they're not both the same. I guess because this one's got an x on the bottom. I didn't. I didn't notice it, but this is the only one that matches this down here.
Okay. Okay. All right. And I will share my screen. Oh,
All right, so this is a new set of product problems, and yeah, we'll look at these together here.
This doesn't look like fun.
I'm with you. Like I like math, but I understand these topics aren't all that interesting, and you know that you're we'll just do the best we can here. So
Okay.
one of the things that like it might make this easier is if we actually combine a few things first. Like you can combine the 9 and the -5, and that makes -45. Is that okay? Is that clear?
Yeah.
Now x to the 6th times x to the 5th. When the bases are the same, you add the exponents. So it becomes x to the 6 plus 5, which is 11. And then you do the same thing here with the y. Y to the 9th times y to the 7th. You add the exponents. 9 plus 7 is 16. So on the bottom, there's a 1 here, so we can multiply 5 times 1. That's 5. There's nothing to multiply the x with, but y cubed and y squared. You add the exponents. 3 plus 2 gives you 5. If that was clear, hopefully, hopefully we can, because you'll see this again in the next problem. We'll do this again, but like that's the first step. So the next step I think is the easier one, which is where you're going to cancel. So it's really 3 separate problems.
Divide and subtract pretty much.
Yeah. So this one's -9. That's not real helpful because they're all -9, but you have 11 up top and 5 on the bottom. So like you said, you subtract. 11 minus 5 is 6. 16 minus 5 is 11. And thank goodness there's only one there that matches that.
Cool. That is actually pretty easy though.
It's not bad, but it has the appearance of being.
Bad.
Yeah. Like most things in math, like once you feel like you got something down, they just increase the difficulty, and it feels like you don't know how to do it.
Yeah. That's never fun.
Yeah.
Okay, same thing.
So this one's really similar, really similar. Let's work it out together, and then maybe the next one you can try on your own. I'm not sure, but let's. I'm grabbing a snip here, and we'll work it out here. So let me share screen. Okay, so find the product again. So just drawing these little connectors here. So 6 times 7, that's 42. x to the 10th times x to the 5th. That's x to the 15th because you're adding. Y squared, y cubed, that's y to the 5th. 7 times 3 is 21. X to the 6th times x squared is x to the 8th. And it is important to kind of line them up. X is under x's, y is under y's. There are other ways to do this that could be considered faster, but this will always work the way we're doing it.
Okay. I'm fine with whatever way.
Yep. So could you carefully try to do the division, at least for the first two, and tell me what you get?
Yes.
Or I guess for the x, give me the x here. We got 15 minus 8, that's 7. And then 5 minus 9, that's -4. So you'll notice none of these answers are written this way. But what we can do is use the following property. If you have a number to a negative exponent like this, it equals 1 over the same letter, but to the positive exponent. See how these are just switched in sign?
Yeah.
So this is 2x to the 7th times 1 over y to the 4th. And you can see that that becomes 2x to the 7th over y to the 4th. So it looks like we're down to this one here. All right, well, that does take us to the end of our first hour. I'm going to need a short break. Please connect to that 1 p.m. booking email, and we'll just start right back here or with whatever else you want to work on. Thanks so much. I'll see you shortly.
Thank you.
Okay.
See you in a bit then.
Okay.